Welcome to Math Made Easy. We're all about breaking down the numbers that shape our world. So, March 23rd. To you, it's probably just, well, another day on the calendar, right? But what if I told you that in the world of mathematics, this one single day is kind of a big deal? A really big deal. Stick around, and I'll show you exactly why.
It's pretty wild when you think about it. On this one single day, just scattered across centuries and all over the globe, these absolutely brilliant minds were either born or they passed away. And each one of them left this incredible mark that helps shape the world we live in right now. So, okay, let's dive in and meet them one by one.
All right, first up, we're going to start with an idea that, well, it powers literally everything we do today. I'm talking about software.
I mean, have you ever really stopped to think about it? Who were the very first computer programmers? Long before you could just tap away on a laptop, how in the world did those first giant computers actually get their instructions? Who were the pioneers who first figured out how to actually, talk to a machine?
Well, the answer to that question takes us back to a machine that filled an entire room. Seriously, a whole room. And it connects us to this incredible woman who, as it turns out, passed away on March 23, 2011. Her name was Jean Bartik.
So, Jean Bartik, she was one of the original programmers for a machine called ENIAC. And ENIAC was the world's first general-purpose electronic computer. But here's the thing that's just mind-blowing. She and her team, they weren't handed some instruction manual. No way. They basically had to invent programming as they went. They had to figure out how to take these super complex math problems and break them down into tiny little steps the machine could actually handle. And in doing that, they came up with fundamental techniques like subroutines. You can kind of think of subroutines as reusable mini programs, almost like little recipes a computer can follow again and again. And guess what? Those are still the absolute building blocks of all software today. So here's the big takeaway. The thing you got to remember. Every single app on your phone, every piece of software on your laptop, it has a direct line, a direct ancestor in the work of Jean Bartik and her team. It's so true. The software that's literally in your pocket right now, it all started with these amazing women programming a machine the size of a room. Okay, so we've just seen the birth of software. Now let's stick with our magic date, March 23rd, but we're going to jump in a time machine and rewind the clock way back, all the way to 1754. And trust me, we're heading into a very different kind of problem-solving environment. Just put yourself in this scene for a second. Could you do it? I mean, really, you're in the middle of a raging battle, the air is thick with smoke, cannonballs are literally flying over your head, the noise is just deafening. In all that chaos, could you sit down and focus on some really complex math? Well, it turns out there was a man who could. On March 23, 1754, a guy named Georg Vega was born, and he did exactly that. He was an artillery officer, and during the siege of Belgrade in 1789, his fellow soldiers were just stunned. They'd look over, and there he was, totally calm, just calculating logarithms while the battle was exploding all around him. So what was he so busy calculating? Well, Vega's entire life's work was all about creating these incredibly precise logarithm tables. Now, you got to remember, way before we had calculators on our phones, or calculators at all, these huge books filled with numbers were absolutely essential. They were kind of like the ultimate cheat sheet for hard math. They let you turn a really nasty multiplication problem into a much, much simpler addition problem. And for more than 100 years, scientists and engineers, they all relied on Vega's tables to build and discover pretty much everything. And if you want proof of his insane focus, get this. In that same year, 1789, while the war was going on, Georg Vega calculated pi to a new world record. He got it out to 140 decimal places. I mean, wow, that level of precision, that dedication. That's the kind of thing that completely changed the face of science and engineering. Okay, so we've gone from the room-sized computer to the battlefield. From calculations that literally helped build our physical world, we're now jumping to another March 23rd story. And this one stretches our understanding of the universe itself. Here's a question for you. How on earth do you draw a map of a black hole? I mean, we see them in sci-fi all the time, right? But think about what a black hole is. It's a spot in space-time where gravity is so intense that nothing, not even light, can get out. So, how could you possibly visualize that? How could you even begin to map it? Well, believe it or not, the answer starts on, you guessed it, March 23rd. This time in 1897 with the birth of John Synge. He was an Irish mathematician, and he was brave enough to take on the totally mind-bending ideas of Albert Einstein. Synge's secret weapon, his superpower, was geometry. He
He had this brilliant insight that he could use drawings, what we now call space-time diagrams, to take Einstein's super abstract theories and make them into something you could actually see. It was almost like he was drawing a map of the universe, but his map included time as a fourth dimension, like another direction you could travel in. Just an absolute pioneer. And get this, back in 1950, he used this whole geometric approach to mathematically explore what it's like inside what we now call a black hole, decades before we ever had an image of one. He literally gave physicists the tools to navigate the cosmos. And that, right there, is the beautiful aha moment behind his work. John Synge didn't just map some physical location. No, he drew a map of time itself. And in doing so, he helped us understand the very fabric of the universe. So let's just take a breath for a second. We've met three incredible people, right? All of them tied together by one single date, March 23rd. We have a software pioneer, a battlefield calculator, and a cosmic map maker. Pretty amazing. You know, we've gone from the complex circuits of the very first computer to the kind of precision that powered 18th century engineering, all the way to the geometry of the cosmos itself. These three people, from totally different times and places, they were united by something way, way deeper than just a date on a calendar. See, every single one of them, in their own unique field, was asking the exact same fundamental question. What is the hidden pattern here? They all had that deep, innate human drive to find order, to find structure, to find some kind of logic in all the chaos around them. And it's because they didn't just ask that question, that they chased after the answer relentlessly, that our world looks the way it does today. It's why we have computers in our pockets. It's why we can build these incredible structures with pinpoint precision. And it's why we can even start to wrap our heads around the mysteries of the universe. So that kind of leaves one final thought, a question, really, for you. What hidden patterns are out there, just waiting for you to discover? Hey, if you enjoyed digging into the hidden patterns of math history with us, do me a favor and hit that like button and subscribe to the Math Made Easy channel